Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides even more practice using corrections for sample size. Let's get started. So first up, we've got ejection seat redesign for fighter jets. So there was a day when only men were fighter jet pilots, but that changed with the changing times, and eventually women were allowed to become fighter jet pilots as well. When this happened, engineers needed to redesign the ejection seats, which had been originally designed for only the men. Okay, and these men weighed between 140 and 211 pounds. So if we assume that the weights of women are normally distributed with a mean of 165 pounds and a standard deviation of 45.5 pounds, then first, what is the probability that one randomly selected woman will weigh between 140 pounds and 211 pounds? Go ahead, stop the video here and see if you can work this problem, and then come back, we'll see how you did. Okay, let's see how well you work this. So, you're in StatCrunch. Here's the value you should be putting into your calculator. So, 165 for the mean value, 45.5 for the standard deviation. And then notice I'm using the between option there in the StatCrunch calculator so that I can put in the two values, the 140 and the 211, and out comes my probability of 55%. Now, what is the probability that 36 randomly selected women will weigh between 140 pounds and 211 pounds? Again, stop the video, work this in StatCrunch, and then come back, we'll see how well you did. So in StatCrunch, here's what you should be getting in your normal calculator. So notice we have to make an adjustment here for our standard deviation value since our sample size is greater than 1. So I have to take the value that I used before and then divide it by the square root of 36. So that gives me my adjusted standard deviation value. And you can see that the probability it comes out, 0.9995. Okay, 39 certain, that's, yeah, you're pretty close to 1 there. So it's almost a certainty that 36 randomly selected women are going to weigh between 140 and 211 pounds. Now, last question for this problem. Which probability seems more relevant to the redesign of the ejection seat and why? Is it the probability of 1 randomly selected woman or the probability of 36 randomly selected women? So what say you? Which do you think it is? Okay, I give you a moment to make your answer, and I hope you said the first probability. The probability of 1 woman is the more relevant one because only 1 woman is going to be sitting in the ejection seat at any one time. So you're not going to select 36 that are going to be sitting in the seat at the same time. You're only going to be selecting 1 to sit in the seat at the same time. You might select 36 to, sit in turn in the seat, but, even with that, there's only 1 person sitting in the seat at any one time. And so it has the same effect of just selecting 1 person randomly. And so that's going to be the probability that's more relevant. Let's look at another example problem. And this one is actually based on a real life incident. Happened at Lake George in upstate New York. So Ethan Allen tour boat capsized. 20 of the 47 passengers on board drowned. The boat had been rated to carry 50 passengers or passenger load limit of 7,000 pounds force. But that rating was based on a 1960 assumption that the mean weight of passengers is 140 pounds. Well, obviously that assumption probably not the best one to be making because since 1960, the weight of the average person in this country has actually climbed. It's gone up and it's continuing to go up. So, that assumption is probably not the best one to be making. But if we assume the boat is loaded with 50 male passengers and that the weights of men are normally distributed with a mean of 189 pounds and a standard deviation of 39 pounds, what's the probability the boat is going to be overloaded because the 50 men have a mean weight greater than 140 pounds? Let's go ahead and stop the video, see if you can answer this question, come back and we'll see how well you did. Okay, let's see how you did with this. So I'm going to solve this in StatCrunch. So there on my normal calculator in StatCrunch, here's my mean value of 189. Notice the standard deviation value I'm using is not 39. Again, I have to make an adjustment because my sample size is greater than 1. So if I take the 39 they give me and divide by the square root of 50, since 50 is the sample size, I get 5.5154, which I stick in there for my standard deviation value in the normal calculator in StatCrunch. I want the probability that there's a mean weight greater than 140, so I put that in the probability field and it counts out. Look at that. The probability is 1. That means it's a statistical certainty that the boat is going to be overloaded. Yeah, I'm saying that's probably not the boat you want to be getting on. Let's look at this problem again. So after the accident, New York State regulated a new assumed mean weight because they recognized that that 1960 assumption was just really outdated. So let's update our assumption and then let's make a new rating for the boat. So we did that. The assumed mean weight is now 174 pounds, which, okay, I'm sorry. I just 174, it still seems a little low. But, okay, so the boat's then going to be rated at carry only 14 passengers or load limit of 2,436 pounds. So let's assume that all 14 of those passengers are going to be male. What's the probability the boat would be overloaded because the mean weight is greater than 174 pounds? Again, stop the video, get a StatCrunch, see if you can work this, then come back and we'll see how well you did. Okay, let's see how you did with this. So there in StatCrunch, again, notice that I'm using the same mean weight for the distribution that I was using earlier. Okay, the new assumed mean weight of 174 comes in here to be my random variable. Of course, I'm making an adjustment for my standard deviation. I have to take that original value that was given, the 39, and now I'm going to divide by the square root of 14. So this gives me a new standard deviation value of 10.4, which I stick in there in the field. And now when I press compute, I get a probability of 92%. So with this new, assumed mean weight, we've got a 92% chance that the boat is again going to be overloaded and people are going to die. So, would the new rating appear safe when the boat is loaded with 14 male passengers? Oh, look at what we got. What say you? Well, I hope you said that, yeah, it's not really safe. I mean, 92% chance of overload, that's still pretty high. I mean, granted, it's not the 100% that we saw earlier, but, 92%, yeah, that's not really much of a safety improvement there. Granted, you're moving in the right direction, but you need to move a lot more in that direction in order to be, have a boat that's really reasonably safe. That brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. We'll see you in the next video.